Sir, it should be like pink okay.
Just it is working, sir. I will send you to WhatsApp, sir. share WhatsApp. System
Hello, good afternoon, everyone. Sorry for the delay. The event is about to be started. See, the event is going to be shared in YouTube also. It is in process. On the issue, I mean, we thought of just conducting a internal closed webinar just good afternoon, participants and delegates. People are joining. Let us start the event in just a few minutes. The issue is
పంపించండి మీకు వాట్సాప్ చేసేసాను.
so good afternoon, everyone. See this, it's my privilege to say that this program is going to be conducted at Bapadla Engineering College and in collaboration with Degree Lecture Company in Delhi. The speaker Anand Kumar Mishra is an experienced speaker. Okay, shall we start, sir? Yes,
Okay.
now, just a minute, sir. Let the introductory program, a few remarks from our head of the department. I request head of the department, T. Nancharaya sir, to give opening remarks.
Thank you, Sen Garu. Good afternoon to all. Respected today's chief guest and speaker, Anand Kumar Mishra, Senior Product Trainer, 3D Dexters, and organizer Hussein Garu, and technical support given by Mr. Samir Garu and other faculty members of our department. and all other faculty members, and my dear young student friends. A very good afternoon to all of you. At the outset, I welcome all you for today webinar on a roadmap of 3D printing technology conducted in association with 3D Dexter. And
Sir, your voice is probably you are muted, sir. HOD, sir.
sir, is it visible, sir? Not. Hello.
Yes.
From the starting, there is no. Can I start,
Yes.
sir?
Yes, sir.
Okay, okay. Good afternoon to all. Is it audible?
Yes, audible, sir.
Okay.
Yes,
Good,
yes.
good afternoon to all. Respected today's speaker Anand Kumar Misra Garu, senior product trainer, and to organizer Hussain Garu, and other beloved colleague friends of our department, and my dear, a very good afternoon to all. At the outset, I would like to invite all today's webinar. I would like to, on this contest, I would like to thank to the our speaker Anand Kumar Garu Misra. Whenever we our organizer asked a request, he accepted our request and organizing an event at our college platform, Bapatla Engineering College platform. Thank you, sir. Thank you very much for your acceptance. Friends, as we know, the 3D printing technology is one of the advanced manufacturing technology, which the manufacturing industry is changes from day to day, vastly varying, very fastly varying the manufacturing industry day to day. So there is instead of a metal removal, by adding the metal can get the product, and nanotechnology like this one by one it is going on. On this context, how the product, so therefore any doubts, any clarifications, or you required any further assistance, you can closely interact with our speaker Anand Kumar Garu and clarify your doubts, so that it is very useful to your career in the manufacturing industry. So to develop our ourselves and at the same time industry also. So now once again I thank to the resource person, and I invite all the students friends to this webinar, and have a nice day. So to continue the session with our resource person. Thank you all. And I hand over to the Hussain Garu, to the organizer, for further proceedings.
Thank you, sir, for introduction to the program. Now let me take an opportunity to introduce the speaker, Anand Kumar Mishra. So he has several skills in public speaking, additive manufacturing, design thinking, CAD modeling, 3D parametric softwares, 3D printing slicing softwares like Cura and other softwares. He is associated with 3D Dexter, right, Delhi, as senior product trainer, and he has experience in he's an experienced STEM trainer for leading educational spaces, responsible for dedicated sessions. He has an experience of arranging 500 plus technical workshops at various places. He successfully implemented 3-day technical program, for different colleges, for a group of 45 faculty members in different places of India. He has contributed to curriculum, and he has developed various robotics and electronics content, and many more. Right? He has developed workshop content for different workshops conducted at various places in India. He holds a bachelor's degree from Biju Patnaik University of Technology, Odisha, right? And without much, without a long introduction, because everyone is waiting for the webinar to start, right? I hand over the session to Anand Kumar Mishra, Mr. Anand Kumar Mishra, right, who have accepted and being a speaker for this session. Thank you.
Thank you, Hussein,
you
sir.
can- Okay, sir. You can start, sir.
Okay. Thank you, sir. Thank you for giving me an opportunity taking up session. Today's session will be a knowledgeable one, and I would request all the students to learn as much as possible. Right? So, moving forward in this session, what we are going to learn today. Right? Basically, I will be telling about the basics of 3D printing, what 3D printing is all about. We will look at the application or the fields where the 3D printing is being used exclusively. Alright, then I will be having I will design something. I will show the process of 3D printing, how 3D printing is being done. Alright, then I will be showing the different additive manufacturing technologies that are available in the market. What are the raw materials that are specifically used for 3D printing? Also, one major thing, I will be trying to take out all the myths that are about the manufacturing market, and then we will have a small market study about the job opportunities in the 3D printing field. Alright, now talking about me, my name is Anand Kumar Mishra and I am a senior product trainer at 3Dector Education. So I have been actually taking up sessions regarding additive manufacturing and mostly design thinking. So my company 3Dector Education, what they do, we are actually a training company in the field such that we try to train as many as people as possible, not only students but also faculty members, and in the corporate sector we also train people about this 3D printing technology. In the meanwhile, we also manufacture our own 3D printers. Okay, we have a manufacturing facility in Delhi and we manufacture our own 3D printers. Alright, now till now we have been hearing a lot about 3D printing and additive manufacturing. So the basic meaning of 3D printing or additive manufacturing is basically to manufacture something or to create something, we are adding the material layer by layer. Now imagine I have to create a block like a square cube, and by going by the normal subtractive manufacturing method or traditional manufacturing method, what we do, we take a larger block, we cut down it to the required cross section. But in additive manufacturing, we do not cut down anything, we simply add materials layer by layer. Alright, now there are different terms that are actually used in 3D printing like additive manufacturing, rapid prototyping, digital direct manufacturing. Alright, now how is this process being actually done? We will be designing something on a CAD software, computer aided design software. Now we can use any software like SolidWorks, CATIA, SketchUp, Rhinoceros, any software that is available, we can design something. Once we have done that, we do slicing. Okay, we will creating a G code. Basically, it is like creating a language which the 3D printer can understand. Now we add our raw material to the 3D printer and our final product is ready. Alright, to describe what 3D printing is a bit more, you can see this image. Now in the upper section you see I have a block over here, and using subtractive manufacturing like a milling machine, we are removing the excess particles. Alright, we are removing all the excess particles and we get the final desired structure. Alright, now in additive manufacturing we do not have any object, we will be simply depositing the material layer by layer. Alright, we will be simply depositing the material layer by layer as you see in this picture. Alright, and the final product is ready. If you compare with these two, you can see the material wasted is very low as compared to subtractive manufacturing. Okay. Also, now prototype means the first product that is actually made for testing purpose. Alright, for modeling, testing, to showcase, we create prototypes. Now, if we create prototypes using the traditional method, it is highly costly and it will actually take up a lot of time. So what we do, most of the prototypes nowadays, they are being made through additive manufacturing. That is why the term here was rapid prototyping. Alright, now two advantages that I am going to show you is in the screen right now. To the left hand side, you see a very complex object is over here. Alright, the complexity is high such that using traditional method of manufacturing, we cannot create such an object. Right? Now this kind of structures can be created using 3D printing only. There are different ways or different technologies used in 3D printing. We can use that to 3D print these objects, right? And another huge advantage of 3D printing is to the right, this process. You see, from the top you have a object and you have reduced the mass of the object to such an extent that the material is only available in the places where there is high amount of stress over there. So this process is this complete process is known as topological optimization. Now the final object, as you see, it is the design has actually become a lot of what you say complex, and it cannot be created using traditional methods. So for getting this kind of structures, very advanced and like the term that is mostly uses biomimicry, resemblance to the human body or the structures in the human body, right? So we do that, we can actually do that using 3D printing, such kind of structures. Alright, now let's move to the application areas in which sectors actually the 3D printing is being utilized. The most first important thing that I would say is research and development. All the research and development fields that are in our country as well in foreign sector, they have utilized it to create as many prototypes as possible because it is highly cheap and the quality is better. Now, as I have just shown you, there was a material reduction through topology optimization. So aerospace, automobile, those industries, they are trying to reduce the weight of their product. So they have been utilized in the final product as well, not only to create prototypes but also to create final product also. Alright, now one of the sector, that is biomedical sector, this is a sector in which the highest number of patents have been registered in 3D printing. Alright, because I will show you the example, because there is a term called customizer, right? So customization has impacted so greatly that the medical industry has actually accepted the usage of 3D printing to a greater extent, right? So let's look at that. Healthcare and medical industry. The first thing is, to the top you see an image over here. Basically the scientists are trying to 3D print organs, right? They are trying their level best, they are researching on it to 3D print fully functional organs. Right now what is happening is, we need a donor for a kidney transplant or a heart transplant, right? We need a donor. But imagine that, suppose if we required a lung or a kidney, so what we can do, we can simply 3D print a fully functional organ and we can use that. So scientists are trying to create that. They have 3D printed lungs, but it was, or a small kidney was 3D printed, but it was not fully functional. So they are trying to make it fully functional, right? In the same way, to the just below it, you can see a human fetus. So in Japan, still the babies that are born, they have defects during the birth, right? So doctors, what they are trying to do, they 3D print the fetus so that they would be ready with they will be better ready with proper tools while operating the child, so that there will be less amount of blood loss and the child can easily complete. All right. Now, as I told you about mask customization. Now, customization means every person's need is completely different. The shape and size that is required for each person is completely different. So in the top you see this is chocolate or brownish color object. These are hearing aids, right? As we know, the fingerprints of a humans are completely different. In the same way, the earlobes of a person is different. So the hearing aids, they require customization. So each person has to be given a different set of hearing aids. Now this is being done nowadays completely through 3D printing. As you see the data, 96% of the hearing aid are now 3D printed. Alright. Now another thing, to the right hand side you see we have a Siamese twin child. So what had happened is they have a joined head while they were during the birth. Now scientists use 3D printing to they scan the head portion, and the 3D printing, that using 3D printing they created the child's skull, and they learned how efficiently they can do the operation. Right, you see the data is over here. The surgery time was reduced from 97 to 23 hours. Right, so this is how 3D printing is actually helping to reduce the operating time, and also the blood loss has been reduced and minimized. Right, now as I told you, scientists are trying to 3D print organs. Now see, this is a kind of lung. Okay, it is not functional, but they have used tissues to 3D print also lung structures. Alright, now in the most important thing is prosthetics. Now suppose a small child has met with a accident and he has lost his arm. Now throughout the age he starts growing up, so he will be requiring a different set of prosthetic arm throughout his life, right? So as long he is growing, he has to require to change the prosthetic arm, right? So that can be done through 3D printing. The biggest advantage here is the cost effectiveness. The normal prosthetics that are actually available in the market is costly. So actually 3D printing can create highly accurate prosthetics that is highly cheap as compared to the traditional method. Alright, now in the same way you see, this is how doctors create the structures of the organs to study before they operate. Right, now just below it we have a damaged skull. We can use 3D printing to create objects in this shape. So basically what we do, scan the patient's skull, we create the object using a software and 3D print the object according to the requirement. Right, now this technology, right, like this structure, it is not possible, like there are a lot of different contours, the design is completely different. So these are actually possible through 3D printing. Right, next is aerospace. Now a lot of advancements have been done in aerospace, like to create the structures of the planes and to make research in such a way that they can reduce the weight of the plane to improve the performance of the plane. Okay, so this is being done. See, Airbus now has a record number of 3D printed parts on the new A350 XWB aircraft with around 1000 parts. Right, see, you can see even it is not a prototype, they are using 3D printed parts in their final product also. Right, now see, NASA rover currently contains over 70 FDM 3D printed parts. Now what is the advantage is, suppose there are very complex design has been created and we have to go through 3D printing to create them. Right, that can be only done through 3D printing because the traditional method of manufacturing, they do not allow to create complex method of designing. Okay, now moving forward, let me show you an example. Okay, this is a case study which shows the complete comparison by going through traditional manufacturing and 3D printed rocket. Actually, it is a case study. The case study is Terran rocket. Okay, now this rocket has been 3D printed, completely 3D printed, and you can see the comparison. By using 3D printing, the number of parts has been reduced to 1000 parts or less than 1000 parts. By going through traditional manufacturing, you see there were around 1 lakh parts. The time duration for build time is 24 months, and it has simply reduced to 2 months. This is the direct comparison. You can see 48 months iteration time, 6 months iteration time through 3D printing, right? So basically 3D printing is reducing the time, it is reducing the number of parts. Okay, so this is a huge success as we are talking about the Terran rocket. Alright, now the next thing is the automobile sector. As I told you, by utilizing this 3D printing technology, we can create complex objects like this. This is chassis of a car. See, this hollow part has been carved out to reduce the weight. Okay, these hollow surfaces, they have been carved out to reduce the weight and to improve the performance of the car, right? Now just below it we have a car, the first 3D printed car. It is an electric car known as Urbi, URBEE. It was the first 3D printed car in the market. Alright, so complete chassis has been 3D printed, and it is a complete electric car also. Alright, now see, a lot of parts of the car is being 3D printed nowadays, such that the efficiency can actually be okay. Now for increasing the performance, like there is a very fast performing car, they are like Ferrari and all, they are trying to 3D print the parts, okay, in such a way that they would reduce the friction in the internal parts, and they can reduce the weight of the car actually, right? They are trying to do that. Next, going to our education and research field. Now the best thing about this is we can create prototype very fast. Okay, we can actually create prototype very fast. As you see in the first structure, we have this is a hydraulic arm over here. Let me take a pointer. Okay, now this is a hydraulic arm. So one student actually has 3D printed all the structure over here. Okay, a student has actually one student actually has 3D printed this complete hydraulic arm, and
ఎవడ బయటికి వెళ్ళిపోయినా సార్ డ్రిల్ మాస్టర్ పెట్టేసాలే నా డ్రిల్
alright. Okay, so basically the student wanted to test the hydraulic arms available here. Okay, now the traditional method, it was costing him very high. So what he actually did is he used used 3D printing to create this hydraulic arm. You can see all the parts have been 3D printed except the syringes, right? He used syringes for transferring the hydraulic energy. Rest all parts have been 3D printed in this mechanism. Okay, now it is playing a huge role in education as well as research industry. Like, you can create the prototype in a very fast manner. Alright, now a huge advantage in this is mass customization. As I told you, right now the demand for individual needs is increasing. It is completely like suppose you want a car and you want the car to be of your design. Okay, that is known as customization. So the demand is increasing, and the demand is only favoring 3D printing. That is the big thing. It is completely different to mass production. Like, we have a single design of a car, we are creating a thousands of car of the same design. Now we will create 1,000 car of different design according to the customer's need. That is known as mass customization. All right. Now moving to moving into our customizable products, what is happening is this drone industry. Now the drone industry is highly rapidly evolving in our present stage. What is happening is they want lighter, faster and stronger materials. So as the study in the materials is also increasing rapidly, the same way the designs are changing rapidly. So the design changes can only be implemented by this technique, right? Now to the next example, what is happening? So the dentures are nowadays 3D. The main requirement is high precision. Okay, so that precision can and also customization. So the dentures actually they are made according to the fit of the customer. So we need precision as well as high customization. So we use 3D printing. I will show you which method is actually used for 3D printing the dentures, right? Fashion industry and the food industry, they are also trying to use this technology, right? Now see, this design, it cannot be created by any other method other than 3D printing, right? This can be only done through 3D printing. Same goes for food. Now food industry, what they are trying to do, they are trying to create customizable products using 3D printing. So there are even companies or even stores in India also. Now they have been using 3D printing to create food using 3D printing. In the screen lower portion you see there is a plunger over here in the lower portion of the screen, and from the plunger the food material is coming out. It is mostly in semi-solid state and it is being added layer by layer. Alright, you see the 3D printed foods in the lower portion of the screen. Now in this screen a lot of customizable products you can see. Top left corner you have these earphone pieces. They are according to the customization, right? Next is the drone industry which are using the 3D printing parts, and this car, complete 3D printed car is over here. And this is dentures that I just told you. This is dentures. So basically they are customized according to the requirement of the customer, right? Now here you see in architectural sector, even scientists have used concrete to 3D print not only houses but also bridges. So this is a bridge in the China. So this has been completely 3D printed. All right. Now Nike and Reebok, they have also started utilizing 3D printing to create customizable shoes. Right, the word is customization, mass customization. Right. Now we have seen all about what you say applications of 3D printing. Now let me show you how it is being actually done. All right, how it is been actually done. So let me stop sharing this screen right now. I will share a screen of my software. Okay, now you can use any software for designing. Okay, you can use any software for designing. It may be CATIA, it may be SolidWorks or any software. Now first thing is you have to utilize the tools that are available with you. Okay, for example in SolidWorks there are a lot of different variety of objects that and tools that can be used for creating very complex design. So we are using SketchUp because for basic beginners it is a very basic software and any person can actually learn from this software about the basics of designing. Alright, we have tools over here that create 2D objects and we can convert that into 3D, right? So let me take you a example of a rectangle. Alright, so now see what I will try to do. Okay, I have a pen tool. I will try to create something over here. Alright, now I will try to create something. Alright, let me try to create a keychain over here. Alright, not an issue. I will remove the excess part. I am right now creating only the 2D image. Alright, now I am using this push pull tool. So these are all what you say the 3D tools. So I can convert this 2D. So it is simply a single layer. It is like a simple paper. What I will do, I will push pull it. Alright, let me bring it to the center of the screen. Okay, now see, we have used the push pull tool to increase or decrease the third dimension into that is the height. Alright, I have given something. Let me use another tool. This is an offset tool. Let me create another boundary inside. What I can actually do, I can take it down. I can write my name over here. Okay, not my name. I will write the college name. So what can we actually do is we can design anything according to your requirement, right? So you can use any software as I told you. So this is the college name. So let's bring it to the center. Let's reduce the size to make it appropriate. So I have done designing. Now see, once my designing is completed, now what I will do is I will save this file. Now remember, in 3D printing, for example, whenever you save a file in Microsoft Word, you save it in doc file, right, or Word file. Now while saving in any software like SolidWorks, they will be having this different format, and SketchUp has a different format. Right? For 3D printing, whenever you save your file, you have to save it in .stl format. Right? You have to save the file in .stl format. See, I will be going to File. I will be going to Export STL. I will click on that. Okay. Once it is done, it will ask me where to save it. Okay, I will export it and save it somewhere. Okay, wherever is required. Alright, now let me save it in desktop. BEC. Alright, so I have saved this in the desktop. Now I will be opening another screen. Alright, so what will happen? So now my complete screen is visible. Now what I will do, I will open the file. Okay, so see, in the desktop you see this icon, it is STL format. Alright, now I will be simply double clicking that because I have a software known as Cura installed in my computer. Now it is a very interesting thing because all the settings that is actually required for 3D printing, they are actually done through this software, that is Cura. Alright, so the spelling is C-U-R-A, Cura. Okay, we have to wait a few seconds. Okay, this is the software Ultimaker Cura. So if you want to download the software also, it is a very free software. The SketchUp software is also free. You can use Google to search for SketchUp and Cura, right? Now the advantage of SketchUp is, as I told you, it is very simple and anyone can learn it. The next is Cura. Now in Cura, the huge advantage is, so with 3D printer, and a bit different according to the hardware. Now Cura gives you the advantage that you can add your own machine, right? You can add your own machine according to our requirement or whichever machine you have. Like for example, there are different companies available. So whichever company you are using, you can use that setting according to that given by the company owners. Okay. Now we have to wait for a few seconds for the starting of this Cura. Now my model will be directly inside the software, because as I double clicked on the icon, so what will happen? My model will be directly inside the software. Alright, so I have to wait for a few seconds for the user interface to turn up. Alright, now if you go to Google, if you type Ultimaker Cura, so Ultimaker is a 3D printing company and they have made a open source software. Alright, this is a free software. As I told you, it is a free software. You need not buy this software. Okay, there are other softwares available which are paid version, like for example Flash 4 is a
Excuse me,
company.
Mr. Sir. Just sorry for interruption. Just a minute. Yes,
Alright,
I
alright.
request all the participants, all the student participants to mute your mics. Please do not unmute your mics, because the same program is being telecasted through YouTube also, right? And parallelly it is working through MS Teams and through YouTube. Please uh, don't unmute your uh, mics. Please don't switch on your mics. Always keep in mute mode only. Right? This is the request. But here in MS Teams we are getting a very clear noise. I mean very clear voice. But in the one telecasted in YouTube, there are little disturbances from student side. Since all the students are requested to mute your mics. Right? Okay. Thank you, Mr. Sir. Continue, sir.
Okay, so not an issue, not an issue. Okay, students, kindly mute your mics, not an issue. Alright, now see, now the software that is Cura, it is open. Okay, in the screen you are able to see a box over here, right? Now as I told you, I can add my machine. You see, there are a lot of different variety of machine. Now the machine will be printer. I will go to manage printer. Okay, so whichever machine I want, I can select that. I can either add the machine or I can remove the machine. Suppose let's go to machine settings, right? So all the hardware requirements of the machine is being done here, like the x-axis, y-axis and the z-axis, all the data. So basically the hardware of the printer, the hardware data of the printer, we are entering it over here. Okay, the bed plate, all the size of the bed plate. Okay, is it having a heated bed plate? So all the options we are providing it over here. Now also the nozzle, there is a nozzle, I will be showing you that also. So basically now the data like the filament size, the nozzle size. Okay, nozzle means the part from where the material will come out. All these are available. Okay, now let's see, I will select according to my needs. So if I am attaching a 0.4 nozzle, I have to enter that. If I am changing my nozzle, for example I am using 0.6 size nozzle, I have to enter that. So this is the advantage, as I can use any 3D printer that is available in the market. Alright, now see, this is my object. Now we have designed it in a CAD file. Right, now these are, I am going to tell you some of the what you say, custom things that we actually do. What are the factors that we actually influence here? See, we have got a lot of setting, so I will give you a quick overview actually about all of them, right? So before that, let me slice it so that you can get a time over there. Okay, see, now if you are able to see it in the bottom right corner, you can see 10 hours and 45 minutes. So this object will be 3D printed in 10 hours and 45 minutes. You see, it is a very small object and it is taking a lot of time. 40 grams will be used, 10 hours 45 minutes, right? Now why it is so? Now let me go to the preview option. Okay, now see, it is written BEC. So as I told you, additive manufacturing means printing by layer by layer. Now in this software you can see the individual layers that are actually 3D printed. To the right hand side I am seeing there is a bar or a slider and it is written, let me close it. Okay, this is the slider and here you can see there are 74 layers. Alright, so you can see all the Let me zoom in again. You can see all the individual layers, how they will be 3D printed. Okay, you can observe all the individual layers, how they can be 3D printed. Alright, so we can set all the parameters over here. Right, you can see the first layer, it is completely yellow, that means it is completely filled. Now as you go up, you can observe it is almost hollow inside. Right, we are using thread light structure or grid light structure to fill up. So it is like let me check what is the infill. Okay, the infill is 20%. So the object I have kept 20% infill and 80% is hollow. So this is what I can do in 3D printing. I can make a object look completely filled from the outside, and from the inside I can keep it completely hollow. Right, now see this BEC, inside the BEC it is a grid light structure, and as you go up, the top surface will be covered up. Okay, see it is from layer number 65, 66, okay, so from 67 onwards the top layers they are covered up. Right, so this is how 3D printing is being done. It is will done layer by layer. Alright, now what are the factors that we are changing here? There are 74 layers. Okay, now see the first option is over here, quality. Now the quality depends upon the number of layer. Okay, now how to increase or decrease the number of layers? We are giving the layer height. Right, now if you are using a 0.4 nozzle, so the minimum layer height means more number of layers, so the quality will be good. Now there are two things. If you want better quality, the time of printing will be high. You see 0.15, it is very good quality and it is taking 10 hours 45 minutes. Let me reduce the quality. I will go to 0.3, that each layer height will be 0.3, so that the thicker there will be very thick layers. See the number of layers, it has reduced to 37. Okay, the number of layers have been reduced to 37 and it is taking 5 hours. Alright, so due to, you can see now individual, the object size is same. I am not changing the object size. So what is happening? Simply the number of thickness of this individual layers, it has increased. So the radius has decreased. From the side you can actually observe the layers. So the number of layers, if you are increasing, the quality increases. As the thickness of each layer, it has got reduced very much. We will get very fine layers. Alright, this is how we are controlling quality. Next is cell. So what is cell? There is two things, cell and infill. Let's go to one layer to explain that. So let's see this. Okay, now in this, see, one is infill. So basically inside a 3D printed part, let me close it. Okay, so inside part is completely hollow or the setting is different. So inside part is known as infill and the surrounding outer part is known as cell. Just like a cell of a tortoise, in the same way we have a cell over here. Right, you can see the green and red part, that is a cell. Okay, we can give the data about the thickness of this part, right, the cell thickness, and also the infill we can decide it over here in the software. Alright, now this cannot be done in casting or any other process. It can be done through over here, the material melting temperature of the material. Alright, so all of this data, because the technology that I am going to show you, it is an FDM based technology. So what happens is we are melting a thermoplastic. Okay, so we are setting the temperature, melting temperature of the plastic, and it will be followed. It will be followed like the speed, travel, and all. These are being provided in this Cura software. Alright, now once my software has created all this, once it is done, I have given the required parameters and my required setting is done. What I will do, I will save my file. Okay, now it is a huge file. Let me do one thing. Let me reduce the size also. That is what I can do. I can reduce the size also. See, it is very small now. Let me slice this. 1 hour and 10 minutes. It is taking 8 grams only. Let's see the preview. Alright, this is the preview. There are a total of 18 layers. It is taking almost 1 hour and 10 minutes. Alright, now the next thing, you have to save the file. Alright, I am saving it in the desktop again. Okay, C triple FP BEC. Done. Now I'm minimizing the screen. Okay, this is the file. Okay, this is the file that I will need to transfer to the printer for printing. This is the file, C triple FP BEC. Let me open it in a notepad to see what are the commands actually in this file. I'm right click on let me to open it on notepad. Okay, it is taking some time. Let's wait for a few seconds. It will open up, not an issue. Alright, it's opened. Now I will open it with the notepad. Done. Let's see what's happening over here. Now, if you see in CNC machine we have G codes. In the same way, this is also a G code for our 3D printer. Alright. In the same way, exactly same like a CNC machine, we have G code. We have also the similar G code for this also. You see the motion of the print head, they are all described over here. Okay, G, X, Y, Z, everything, the motion, all this data is actually available over here. So we can know it from here, the motion, right? We give this in the G code actually. So Cura created this G code for us. The motion, at what time the printhead should be at what location, the temperature, what should be temperature, what should be the bed plate temperature, right? So all this thing, it is been given over here, like plus G code, it is given from where to start. All this data is actually available over here. I will copy this file. I am 3D printing. I have to copy this file into an SD card and I will transfer it to a 3D printer. Alright, now let me do one thing. Let me try to show you the 3D printer to you. Alright, let me stop. Okay, I'm stopping my screen share. Alright, so now I'm turning off the camera. Okay, I'm turning on a camera of my mobile phone, I think. Let me see if it's possible. Okay, oh, Hussein sir, are you able to see the printer now? Can you give me confirmation?
Yes, sir, we are ready.
Are you able to see the printer?
No, sir.
Yes, sir.
Okay, okay, alright, alright. Now, alright, alright. Let me do one thing then. Yes, as it is not visible, let me show it through my. I have already recordings of the how to operate a 3D printer. So let me show you that. Alright. Let me open up that for you, and I will show you how to operate a 3D printer. Alright. So okay, let me do one thing. Just a second, everyone. We have our printer over here. So as I am not able to show that to you, I will be doing it through the screen itself. Alright. Now, alright, wait for it. Not an issue. So now what I will do, Okay, right now I think I'm audible to everyone. All right. Let me do 1 second more. One more second left. All right. All right. So my video is ready. Okay, I will be showing it right now. All right. Okay. Okay. Now let me share my screen. Okay. I'm hoping everyone is able to see the screen right now.
Yes, sir.
Okay, great. Thank you for the confirmation. Now, in the screen, you are able to see a 3D printer. Okay. This is an FDM based 3D printer that I am going to show you. I will be telling you how to operate this 3D printer also. Alright. Let's start it. I will be showing how to prepare the 3D printer as well as how to give a print command. Now, what I have done, I have created a G code, right? For like BEC, but is it as it is a recorded video, I will be printing a cube today. Okay, I will simply show how the printing is actually taking place, right? So to the back side of this video, you can also see some 3D printed parts are also there, right? So as I told you, there is no restriction in the type of design you can make. You can create as many type of design as you want. So I am turning on the printer. So as soon as I turn on the printer, the electricity will follow. The LCD screen will be on. Okay, we have LCD screen that will be turned on. This part is known as print head. Alright, so let me first show you 3D printed part. See, as I told you, 3D printing is being done layer by layer. Now if you observe this part, you can actually see the layers over here. So this is what I was saying. So the quality, so if you are increasing the quality, the layers will be less visible, and if you are decreasing the quality, the layers will be actually widely visible, right? You can see the individual layers over here, right? This is a 3D printed mask. Now moving forward to the LCD screen, there are some data over there, like it is saying 28 right now. So as I turned on the printer right now, it is showing the room temperature. Okay, we have to heat it up, right? Actually, so I will have to prepare my printer. So I will be doing it through this knob. Okay, so I give the commands, I control it through this knob. All right, if I click it, I will get options. I can rotate it clockwise and anti-clockwise. So this is a knob that we have. This complete part that you are seeing right now on the screen, that is a print head. Okay, in Cura we had given the setting for nozzle dia, right? So this is the nozzle, right? This is the nozzle from which the melted filament will come out. Okay, this is the hot end part, and from where the melted filament will come out. All right, so next is the heated bed plate. So this is the part where the printing will actually take place, right? On this bed plate, the printing will actually take place. So that is our raw material. As I told you, this technology is known as FDM based 3D printer. This is a raw material that is thermoplastic. Alright, it is PLA, polylactic acid. Now it melts at 200 degrees Celsius, right? So the nozzle should be at 200 degrees Celsius before printing. So this is an extruder part. It will push the filament from the back side. I will place the filament spool over here. It will push the filament into the guide pipe, and this guide pipe is actually going inside the print head. Alright, so this guide pipe is white in color. So through this guide pipe the filament will come, and it should come out from the nozzle. So this is the basic principle. From the back side we are pushing the filament, and the front I have a heated nozzle, and the material should come out, right? That is our LCD screen, and the knob to control it. I have this filament and the most important part is SD card. Now I had created a G code. So basically what I did was I copied the file to the SD card. So whatever file we need to print, we have to copy it into the SD card, and I will be inserting into the designated slot over there. Okay. Right now these are the parts that I told you. Next I will be showing you how to prepare our printer. Imagine that I have to insert the filament. So how to do that? Actually, first thing is the nozzle should be at the melting temperature of the raw material. So the print head is over here. So just below it there is aluminum block. Let's have a close-up view. This is an aluminum block. There is a cartridge for heating it, and below it I have a nozzle. Okay, this is the nozzle part. So I have to heat this block so that the melting of the thermoplastic will take place and the filament can come out. Alright, you can see the screen over here. It is at room temperature 28. There is no target temperature. Okay, there is two temperature. One is for the nozzle, one is for the heated bed plate. Let me show you how to do that. I will click on the knob. By clicking on the knob, I will get more options like prepare, control, SD card, right? So I will go to prepare. How I am going there? I am rotating the knob. Okay, the cursor is going up and down. I will click on prepare. I will get more options. Now the raw material that I am using is PLA. So I have to select preheat PLA, right? I will select preheat PLA. Let's click on that. Now there are options over here. I can heat only the nozzle, I can heat only the bed, but I will heat both. So I will click on preheat PLA. Alright, now see, the nozzle and the bed bed, both of them have got a target temperature. Alright, they have both got a target temperature. Like the nozzle has got 200 degrees as the target temperature, and the bed plate has 70 degrees as the target temperature. Alright, so these all are given through this screen. Okay, we are getting the data, reading of the data in the LCD screen. Okay, now in the meanwhile I will insert the filament manually from the back side. Okay, that is the extruder part. How the extruder works is, there is a gear and pulley arrangement. This is a gear and there is a pulley arrangement. So I will place the spool in the spool holder. Okay, this will facilitate the rotation of the spool and the filament can come out easily. I will insert the filament into the extruder. Alright, now one more thing is, there is a very tight connection, or there is a very less amount of gap between the gear and the pulley. So I will be pressing a lever. Okay, there is a lever. So by pressing that, it will create a gap. Okay, see, by pressing that I am creating a gap. Alright, and through this gap I can insert my filament. You can see the white pipe, I have already inserted the filament. Okay, now after inserting the filament, it is inside this guide pipe. Well, it is mostly translucent. You can see the filament, red filament inside this translucent pipe. I will be manually pushing it from the back side. Okay, you can see the wire traveling. That is my wire, it is traveling, and it will get inserted into the print head. Alright, so basically this guide pipe is giving a direction for the filament. I will check the temperature, that is, it should be at 200 degrees Celsius. Alright, the temperature for the nozzle is 200 degrees Celsius. Now I will push it a little bit more. I will push the filament a little bit more, and the material will be coming out from the nozzle. Alright, so it is ready. My printer is ready to be given a print command. Right, I have prepared my printer now. Right, everything is ready, so I can simply give a print command right now. So these are the procedure to actually prepare a printer. Alright, FDM based 3D printer. I have prepared my printer. Next, what I will do, I will insert the SD card now. As I told you, I have already copied a G code. It is a small cube that I am going to show you. Let me click on there. Okay, done. I've got the command card inserted is the display. I will click it over here. Now see, I have got an option print from SD card. I will click it over there. I will go to the G code 20 cross 20 cross 20 cube. Okay, so this G code we can 3D print now. I will simply click it over here. Now see, there are a few things that is going to happen. The print head will come to a home position. Okay, how does the printer know that what is the home position? There are switches attached. Okay, there are limit switches that are actually attached. Now you can see the Z axis, the bed plate is going up. There is a switch in the back. Once this switch is pressed, it will stop it over there, right? So the X axis, Y axis and Z axis motion is done in the 3D printer. Okay, the small amount of material is coming out. We let it go. Now the printing has started. So wherever we have kept the model in the Cura software, it will go there and it will start printing it. You see, from the back side the filament has been pushed and the material is being deposited. Now another thing I have to ensure is the first layer and the second layer, the both of them should actually stick with the bed plate properly. Okay, there should be very proper sticking of the bed plate. Okay, to ensure that we have this calibration knobs. Okay, from at each corner of the bed plate there is a calibration knob, so I can rotate it according to my requirement. I can increase it or decrease it according to my requirement. So as you see, it has started printing the second layer. Now I can rotate it. So basically it is upon experience. Also important thing, this calibration has to be done for every print for the first layer only. Alright, we are calibrating it for the first layer always. I can increase or decreasing the distance between the nozzle and the bed plate, right, so that my material can properly stick to the bed plate, right? See, the material is coming out from the nozzle just like a glue gun, hot glue gun. It is also working the same principle. So basically, as soon as the material is coming out, we are giving motion to our print head, right? It will move according to the G code that we have created and the material will be deposited. Alright, so by fast forwarding, you see this cube has been 3D printed and many layers have been already put into place. Alright, now observe this thing. The x-axis and y-axis motion is done through the print head. Okay, the x-axis motion and the y-axis motion, it is done through the print head, and there are belts attached. You can see the belts are attached to the print head. Okay, so basically these belts are controlling the motion. Alright, so these belts are attached to the stepper motors. The z-axis motion, like after each layer has been 3D printed, the bed plate will come down by one layer height. So how does the bed plate come down? We have a arrangement, a threaded rod arrangement in the back. I will show you right now. So due to that, yes, that is the bed plate arrangement, movement arrangement, threaded rod. So by each rotation, the bed plate comes down a little bit by one layer height and another layer is deposited, right? So this procedure goes on and our final product is created, right? You can see and observe that. Alright, so now let's see some data that is actually displayed over here in the screen. So once we have given a print command, we will get the name of the print. Alright, now feed rate is 100%. I have not changed some data. Now it is showing when I turned on the printer, it was showing question mark X, Y, and Z. Now it is showing some data like where the printhead is located. Now SD 72% means 72% of our file has been completed. It is not showing the remaining time, it is showing how much percent is completed. Now it is showing 73%. Alright. Next is timer. How much time has passed since I have given the print command? So 18 minutes have passed to since I have already given a print command. Alright. So basically all this data is actually available in the print screen. Alright. So this is how the FDM based 3D printer actually works. Okay. So this thing will, the printing will go on and on till the final layer is created. Alright. So this is how our printer actually works. So now what I am going to do is I will show you something. Go back to alright, let's wait for a few seconds for the slides to come up. Alright, so we have reached till now up to here. Now what is actually happening is, now as I showed you about a plastic, right, as I showed you about plastic, now